Okay, so today for social studies, we're looking at calculating central tendency from data. And that's basically calculating the mean, median, mode, and range. And we talked about those last week a little bit, right? The definition of each. We were looking more at median, I think, at the time. But so central tendency through using those four sort of range of numbers or statistics, it gives you a clearer picture about statistical data. And it's sort of like calculating the sort of the most typical range or the medium range, not to, kind of confuse that with median. And the reason you might want to look at more than just say the average or the median or the mode or any of those is the fact that just one of those numbers can mask what's going on in a data set. I don't know, I might have mentioned this before, that the average number of books an American reads per year is 12, right? And that sounds like a pretty good number. That's about a book a month that based on that average, the typical American is reading. But I know a lot of people that don't open a book, even once per year. So that number is skewed by the people who read a lot. So, for example, my sister, she is an avid reader. She reads book after book after book after book. She has shelf after shelf. She has double stacked shelves with books behind books. So she's well above that average, I'm sure. She probably reads maybe twice that. She might get through about 24 books a year, even more. Who knows? My brother-in-law, my sister's husband, on the other hand, doesn't read a book. Doesn't read one book, right? Great guy, hard worker, but just doesn't have time for it. It's not something that he enjoys. So right there tells you, that those numbers can be skewed. She's probably making up the difference for both him and her to get to that sort of average. And that's the other thing. So if I really wanted to understand a little better about, the typical reading habits of an American, I would also want to know the mode, right? What is the number that occurs most often in that data set? The median, right? What number is in the middle? It could be as low as like 3, right? And the range, that's going to be somewhat helpful as well, because it's probably like 1 is the lowest range, and who knows what the upper range is. When I was in grad school, I was up to like 40, 50 books a year. So, that's going to be skewed. And it doesn't really paint a whole picture. If somebody just tells you, hey, Americans read 12 books a year, and you think, wow, that's a good, that's a good number. They're really, avid readers. But, realistically, that doesn't really tell you the whole story. So let's take a look at our lesson here.
Welcome to the lesson on calculating central tendency from data. This lesson will teach you to calculate the mean, median, mode, and range of a social studies data set. Are you familiar with the term central tendency? Many people aren't. Calculating a central tendency is just another way of saying finding an average. For example, the average age of my students is 27. I have students that are much older than 27, and I have students that are much younger than 27, but the central tendency of my students' age is 27. You can think of the central tendency as being the center or middle of a data set. The central tendency of a data set is the value that is most common or most likely to occur. Back when I was first thinking of becoming a teacher, I looked into how much money I could expect to earn. My friend Edward said that he was making about $45,000 a year as a teacher. Another friend, Andrea, a teacher for 30 years, said she was making about $75,000 a year. After doing some further research, I realized that my two friends were on opposite ends of the pay scale. Edward, who had just started teaching, was still making a small salary for a teacher. Andrea, on the other hand, had many pay raises over her 30 years of teaching. What I wanted to know was the central tendency of a teacher's salary. In other words, I wanted to know what an average teacher's salary looked like. Turns out, the median pay for a teacher is around $58,000. Knowing one or two pieces of data won't tell you much, but knowing the central tendency of a data set tells how the data is behaving as a whole. There are a number of different ways to calculate central tendency. Let's go over them.
All right. Right, we talked about median, right? That's the number in the middle. So what he's saying there is that's about representative of the middle number, $58,000 per year for a teacher. And as you mentioned, obviously, if you've been teaching for 30 years, you have certainly, received raises. You've received, cost of living raises and stuff like that. Because of your experience, you might get, bumped up there. Other, training and stuff. So just like every other job, you don't start with a high salary. You work your way up. So there's going to be a whole range. A first-year teacher, making $45,000. Somebody's been teaching for 30 years, $75,000. Lots of people are going to be in that middle, right? So he's talking about what is the overall behavior? What kind of range are we looking at?
You're probably already familiar with the idea of finding a mean. A mean is just the average of a set of numbers. This table shows the number of polling centers across 4 different counties. If I wanted to know the mean number of polling centers for these counties, I'd start by adding up the polling centers. That comes to 24. Next, I'd divide by the number of counties, 4. 24 polling centers divided by 4 counties is 6. Even though no county has 6 polling centers, the mean number of polling centers for these counties is 6. Do you see how County D has a lot more polling centers than the other 3? This is an outlier. An outlier is when one data point is far outside the range of the other data points. In this case, the larger number probably means that the County D has a larger population. They might need more polling centers. Here's the problem. Mean isn't the best way to calculate central tendency with this data set. Averaging this data makes it look like most counties have 6 polling centers. As you can see, the other counties actually have between 1 and 4 polling centers, way below 6. The outlier is throwing off the average in a way that could be misleading. Mean is best used when you're trying to calculate the central tendency of a lot of data with few outliers. For a data set like this one, you might be better off calculating the central tendency using the median method. But I'm getting ahead of myself. First, let's see if you understand how to calculate the mean.
Yeah, so just like I was saying, particularly if you have a small data set, an average could be really problematic. If that's where range sort of comes into play too. What is the range between the numbers, which will be helpful. But let's take a look here at understanding how to calculate.
What is the mean number of days worked by a representative in this passage?
Right. So what we do, and I'll have to pull up my calculator here. So this is just work week of a state representative. Not really that important as far as what we're looking at. But it says Brand was concerned that his state's House wasn't getting much work done. He was curious as to how many hours of actual work his representatives were doing. Over the course of a week, he did some research and managed to dig up the following data for the week of, July 4th, 2016. So the mean number of days worked by a representative in this passage. Here's the other tricky part when it comes to what they're asking you. Be careful, particularly right in this lesson right here in this unit, because they will ask you specific things about the data that you see, not just all, an average of all. They might ask you for, just an average of a certain column or things like that. But this is going to be all. So we got our employees here. So we add up 15 plus 17 plus 14 plus 22 plus 18 plus 23 plus 17 divided by the number of values that we have. We got 1, 2, 3, 4, 5, 6, 7 different values. So
it's 18.
18. Yeah. So 18 should be our number there. Sure.
Great job. The table shows that state representatives worked a total of 126 hours over the course of the week. If you divide the number of hours worked, 126, by the number of representatives who worked these hours, 7, you arrive at the mean hours worked that week.
Yeah, 18. All right. So moving forward here.
When choosing a method for calculating a central tendency, you want to consider the data set you're working with. Let's take another look at that polling center's data set. This data includes an outlier. County D has more polling centers than the other 3 counties combined. Using mean to calculate central tendency will give the impression that most of the counties have around 6 polling centers. That's kind of misleading, since most of the counties have far fewer than 6. So let's try using a different method for calculating central tendency, a median. A median is the midpoint of a data set, the number halfway between the highest and the lowest piece of numeric data. To find the median, begin by organizing your data numerically, from lowest to highest. There. Next, find the result that is exactly in the middle. When there's an odd number of data points, the median is just the middle value. There isn't really a middle here, is there? There are an even number of rows. When this happens, you want to find the mean of the middle 2 rows. In this example, that's a 2 and a 4. So, I add the 2 rows together and divide by 2 to find the average. That gives us a median of 3. A mean of 6, as I calculated earlier, is nowhere near any of the numbers in this data set. A median of 3, however, comes with 1 or 2 points of every number in this data set. In this case, median does a much better job of representing how many polling centers each county has on average. The outlier is still way off when using median, but then again, it was way off with mean as well. That's what an outlier is. At least with median, we have a better representation for 3 of 4 of the counties in this example. Not bad. Median was the correct choice here. Mean and median assume that you're working with numeric data. That won't always be true. Take a look at this data set. This table represents census information for an American city. As you can see, it includes both numeric and non-numeric data. I'm going to use both types of data to find the mode for self-identified race. Mode is the result that appears most often in a data set. So the mode for the self-identified race category would be Hispanic Latino, since there are more data of that race represented here than any other single race. Pretty straightforward, right? Well, that's it for median and mode. Let's see if you got this.
And so I mentioned mode last week, and in that case, we were working with numeric data. But yeah, like you're saying, it can also be a qualitative thing. So it's what is occurring most. So here, we have a mix. So, if you're looking at a city and the most occurring idea, thing, whatever it may be, in this case, talking about self-identified race, so Hispanic Latino, that is that occurred more than any other of the races that we have there. So it may be numeric, it could be, a qualitative, idea. And then, this is a great example here. You have this, very small number of, this very small data set. And as you said, oh, well, the average is 6 polling centers per county. And if that was your information alone, you think, well, that's not bad. But when you put median with that, you realize that median is 3. Now you can start seeing it's like, oh, wait, there might be a problem here. There's an outlier somewhere. So somewhere, one of these counties is skewing that mean, making it much higher than it should be. So that's what we're talking about here, as far as like, the more information you have, the better off you're going to be.
What is the median water usage and no drought conditions of this data set?
Right. So here, thinking about that middle value, right? The median, the number that comes in the middle, and the mode. So what value basically is occurring most often? And you can see by our choices that mode is going to be, it's text, right? It's not a numeric value. It's going to be a word that we're looking for that appears most often in our table. And then the median, of course, is the number that falls in the middle. So let's take a look here. Yeah, so the table shows the gallons of water used by 7 California cities per person per day. Water used for agriculture is not included. The table also lists the local drought conditions for each city in question. Drought conditions are measured on the following 4-point scale: moderate, severe, extreme, and exceptional. So Palm Springs, 750 gallons of water per person per day. Holy crap, that's a lot of water. Anyway, just kind of that, I don't, well, Palm Springs is a nice rich neighborhood. Maybe, I don't know what I was calculating in there, maybe, watering their lawns and their golf courses and everything else, but that seems like a really, really high amount of water to use. And yeah, Nautica. So our number in the middle. So we have here, like you mentioned before, 2, 4, 6. We have 7 rows, right? So we have 7 rows. We have that odd number. We should have a number in the middle. 320, right? 320 is that number in the middle. That's our median amount of gallons per person per day used. And our mode, right? We have extreme. Extreme drought conditions appears most often in that data set. Yep. So where was it? 320 and extreme. Yeah, the median is 320 and extreme is the mode.
Great job. The table has an odd number of rows, so you can find the median of water usage by looking at the middlemost row. That's Fresno, with 320 gallons. The mode is the most common result. The most common result for drought conditions is extreme. Well done.
Yeah. So there we go. Let's see what we got next.
Last but not least, let's talk about range. Range is a good way to show how much variation there is in a dataset. Range is the difference between the highest and lowest values of a scale. Let's say I wanted to find the range of polling centers listed on this table. If I take the number 17, which is the highest value, and subtract 1, the lowest value, I get pretty simple. Sometimes a data set will have more than one range. This data set could arguably have many ranges. You could go from 21 to 27, or you could go from 21 to 85. You could go the full range of the data set and go from 18 to 85. It all depends on what the question is asking you to do. Suppose that I was asked a question about the ages of students in my class. Maybe something like, what is the range between the age of the youngest student and the age of the 75th percentile? My youngest student is 18. My 75th percentile is 78. If I subtract 18 from 78, I get 60. So the range in this scale would be 60. Let's see if you've got the hang of range.
Right. So we talked about range a little bit, just how to find it, right? It's going to be whatever. Now here, this is where, that idea of, very, looking at the question and making sure that you're getting the right numbers, because it might not be the entire range. It might not be that 18 to 85-year-old. It could be something in between. So it's that value between those two numbers, right? Whatever they are asking you. Yeah, I know, Nilda, we're doing math today. You have to tell Rachel I got you guys doing some math. And then when you guys, this will likely come up in your math class at some point if it hasn't already. So you guys will be ready and prepared. So let's take a look here, what they're going to ask us about.
What is the range of gallons used per day for cities located in extreme drought conditions?
Okay, so perfect example, right? They're asking about just extreme drought conditions. We know that there were several different types of drought conditions. So the range per day of cities located in extreme drought conditions. So that's extreme, right? We were looking at. It was extreme, wasn't it? Yeah, extreme. So our highest value for extreme is 350. And our lowest value for extreme is 265, right? So 350 minus 265 is going to be 85 gallons.
Great job. Range is the difference between the highest and lowest values within a scale. The highest usage of water by a city in extreme drought is Tahoe, with 350 gallons. The lowest is Riverside, with 265 gallons. The difference between the two is 85 gallons.
Right. So it's that value, in whatever the difference is between the whatever highest value they're asking you and whatever the lowest value is they're asking you. Just pay attention when they ask you those questions, that you're not just, kind of assuming that it's the whole range. It could be something in between those numbers. So now we are up to our practice questions.
Now it's time to show that you've learned this concept. Try some practice problems to demonstrate your understanding. There are 8 questions total, but first, I'll show you 3 questions. If you get all of the first 3 questions correct,
we know. So let's take about, let's go ahead and say 15 minutes. We'll go to 12:55. So you guys should have the lesson assigned. It should be showing up in social studies for you. So go ahead and crack that open and take a shot at these 8 questions. Yeah, I mean, Nilda, if you want to, you can submit it if you get the first 3 questions right. You might want additional practice. I'm going through all 8 questions. So I just kind of encourage you maybe to go ahead and do them all, just to make sure that you got a handle on it. 3's the little, little shaky on whether or not maybe you got the whole concept, but it's up to you. So go ahead. Yeah, we'll go about 15 minutes there and work on that. I'm here if you guys got any questions. And I'll go ahead and stop sharing my screen for the time being and pause the video.